Good morning, everyone. Thank you for joining us today for the Understanding LEDs webinar. My name is Beth, and I'll be hosting today's webinar. We'd like to start off with a safety moment. Safety is a core value at PGE, and we would like to remind you to be safe around electricity. As you consider installing or retrofitting new equipment, please keep safety in mind. We would also like to encourage your family and staff to be prepared with an outage kit, and you can visit our website for more safety information at portlandgeneral.com/safety. We would also like to thank the Energy Trust of Oregon and the Northwest Energy Efficiency Alliance for their support in co-sponsoring this series of free energy efficiency trainings that are open to all Northwest utilities and their customers. Before I introduce this morning's presenter, I'd like to show you some tools you'll be using during the webinar. To the right of your screen, you'll see several windows: the Participants window, the Chat window, and the Polling window, which will appear at the end of the session. If you have any questions during the webinar, you can submit them to me, the host, through chat, and I'll ask them of the instructor at the end of the webinar. Because this will be an informal session, if you'd like to share an example or you have a question you'd like the instructor to address immediately, please feel free to raise your hand using the Raise Hand icon, which you'll see at the bottom of the Participants window. At the top left corner of your screen, underneath the Quick Start tab, you'll see several tools, which I will underline here on this slide. One moment. Circle, that is. An arrow tool, a text tool, and a marker, and the presenter will ask you to use these during specific slides during the webinar. And with that, I'd like to introduce your presenter this morning, Mark Whitney. For the past 10 years, Mark has been active with the local Oregon section of the Illuminating Engineering Society of North America, which is widely recognized as the lighting authority. Mark has a long history of providing lighting education to professionals and has instructed all levels of lighting courses offered through the IESNA, as well as lighting classes offered by PGE for their customers and employees. As a lead accredited professional, Mark is familiar with sustainability issues, particularly those that relate to lighting. And at PGE, Mark is a lighting specialist since 1996. And with that, I would like to hand the presentation over to Mark. Mark?
Thanks, Beth, and welcome everyone to today's lighting webinar. Thanks for taking time out of your busy schedules to learn about LEDs and how that knowledge will help you make lighting upgrade decision. This webinar is designed with PG end-use customers in mind, particularly those that qualify for Energy Trust of Oregon cash incentives. However, this LED webinar will be beneficial for all listeners today. LEDs are creating a revolution in lighting because they offer many advantages that other light sources can't provide nearly as well. However, LEDs are not always the best or even the most efficient option now for many applications. So this webinar will help you decide which LEDs are ready for you now and which ones are ready in the near future. So here's today's agenda. And throughout the presentation, I'll be focusing on saving energy, saving money, and providing better quality lighting through a lighting upgrade project. The goal today is to supply you with information about LED lighting and energy efficiency that'll make a difference at your place of business. So we invite your active participation. And one way is by using the annotation tools that Beth just talked about. In fact, I'll ask you to use these tools on the very next slide. And we plan to leave time at the end to answer your questions. So these are the key learning objectives for today. So if you would, please use one of your annotation tools, the ones on your upper left-hand side, to indicate to me which one of these are of most interest to you today. So this webinar will not go in depth on how LEDs work, but I will go over some basics that you should know about. And throughout the presentation, I'll talk about familiar current lighting technologies and what the LED alternatives are. The focus is going to be on retrofit, but new construction applies as well. And some LED applications make sense right now, while some need to mature or become less expensive. At the end, I'll go over how you can get help with your lighting upgrade project. And it looks like most of you want to know what applications are ready now. Excellent, we'll definitely cover those. So you're hearing a lot about LEDs, and there's a wide range of quality and performance, so you need to be informed in order to make good choices. And these pictures represent some recent award winners. Next generation luminaires focuses on commercial and industrial type fixtures, while lighting for tomorrow is more residential. So check out their websites for the winner profiles and more pictures. So this graph illustrates the breakdown of various lighting technologies based on energy consumption. As you can see, residential lighting is dominated by incandescent lamps. The commercial sector uses mostly fluorescents, mostly T8s. Your industrial and your outdoor uses a lot of HID, which is primarily high pressure sodium and metal halide. So when we come over here to the total, when we're looking for this yellow for LED, we're going to see this tiny little sliver in the total. Probably less than 1% of the total is LED currently. But LEDs are expected to have a major impact in all of these categories over the next 10 years. This graph illustrates the dramatic growth that is expected from LEDs in the not too distant future. One thing to note here is that most of the growth is going to come from the replacement of existing incumbent technologies. This graph illustrates the current and potential energy savings for 9 common lighting applications, and this is from a report that the DOE just recently published. So in 2012, we've got about this amount of savings, where this taller bar to the right is the potential for all these applications. So right now, most of the savings are coming from the replacement of common light bulbs and also directional lamps such as PAR 38s and MR16s. In the future, the most energy savings will come from replacing troffers and other fluorescent tube fixtures with LED replacement options. Now this chart illustrates the historical and predictive trend of LED light output and cost. You can see that costs are going down while light output is increasing. And a predictor of this relationship has become known as Haigh's law. It's similar to Moore's law for computer chips. So Haigh's law states that the cost per lumen falls by a factor of 10 every decade, and the amount of light generated per LED package increases by a factor of 20. So this law helps explain why we are experiencing the rapid improvement in LED efficiency and the rapid decline in LED costs. LEDs are a form of solid-state lighting. They are semiconductor devices that generate light. In many ways, an LED is the opposite of a photovoltaic solar cell. So instead of turning light into electricity, LEDs turn electricity into light. And this light is produced through the movement of electrons through a semiconductor material. And you'll see from this illustration that many components are needed to create a practical LED light source. LED lighting is very different from current light sources, and it has a lot in common with the fast-paced high-tech industry. Now this fast pace clashes with the current slower-paced lighting industry. Because of this, a lot of cultural adjustments are going to need to be made. Companies are going to need to change and adjust or be left behind. You will also see a lot of new companies in the lighting world. So how do LEDs make white light? Well, there's two main ways you can do this. The most common and the least expensive is to take a blue, violet, or ultraviolet LED and then coat it with phosphors that are similar to the ones used for fluorescent lighting. The other method combines red, green, blue, and sometimes some other color LEDs. And by varying the intensity of each of these LEDs, you can not only create various shades of white, but also any other color. And you're going to see this method used primarily in theatrical type lighting. So why should we use LEDs? Well, one of the main reasons is because they produce light efficiently. This chart shows the recent development of LEDs and their potential for improvement in the near future. Here you can see other light sources when they came on the scene and the improvements that were made. LEDs came on the scene real recently, and we're seeing a very rapid rise in their efficiency. One of the reasons we want to use LEDs is they can have a very long lamp life, even 100,000 hours or more. An important thing to know is that LEDs are directional by nature. And now this works really well for some applications, but it makes other applications more challenging. While LEDs are small, they all need some type of heat sink. So some fixtures actually end up being very big. Dimmability is a strong feature of LEDs. However, compatibility with existing dimmers is an issue. They don't contain any mercury, which is good. They also don't have UV, and they also don't have infrared heat that radiates out that can be a problem. However, they still have conductant heat. The heat hasn't disappeared. So as a new light source, LEDs have several challenges and issues, and I'll go over some of these. So again, all LEDs produce some heat, and that needs to be conducted away from the source in order to operate efficiency and also to make them last longer. In LED bulbs, there's different ways of doing this. So one of the more common ways is used in having some kind of thermal fins to dissipate that heat. You might have a liquid-cooled LED, such as what's used by switch. Others use active cooling. There's actually little tiny fans inside of this little light fixture to get rid of the heat. One of the things that we need is more lumens per watt. It's currently very good, but the potential is possibly even 200 lumens per watt or more, which is much higher than any incumbent light source. One of the main drawbacks or the current barrier to adoption is the expense of LEDs. And for your demanding applications, we need to get more consistent color and performance. I already talked about dimming. Existing dimmers can be a problem, so sometimes you have to have a dimmer that's made specifically for a particular type of LED fixture. And how do we specify this new technology? We're going to need a lot of education and training. The Department of Energy is taking the lead in developing and promoting energy-efficient solid-state lighting, and the website listed here has lots of information. They do research and development, and these activities are identifying ways to make LED more efficient and less expensive to make. They also promote making as many components as possible right here in the good old United States. Demonstration projects are very helpful by finding out how LEDs perform in the real world. And any new product needs to be tested in order for us to gain confidence in their performance claims. And standards for testing are critical for consumer confidence. One unique thing is that the Department of Energy sponsors product competitions, and this challenges manufacturers to create better market-ready products. A good example of this is the L Prize. And end users, they need help and confidence when choosing to buy LED products. So good and useful labeling is one way to do this, along with some educational resources. So all this work gets us to the objective of having market-ready LED products. The lighting facts label that you see here is similar to a nutrition label, and it gives you important information about an LED lamp. So one of those important things is the light output, which is measured in lumens. This label is also going to give you watts, is the energy required or that will be used when lighting this product. So the lower the wattage, the less energy is required to light this particular LED. The lumens per watt, comparing the two, gives you a term that's called efficacy. So this is like miles per gallon. So the higher the number, the more efficient the product. Over here with correlated color temperature, this measures the color. And this label that's used for LEDs, you can actually see approximately what that color looks like, or gives you some clues about that. So cool colors over here are going to be between, say, around 3600 and 5500 K, where the warmer lights are going to be 2500 to 3000. So cool white light is usually better for visual tasks, while warm white light is usually better for, say, living spaces, for example, because it casts a more appealing light on skin and clothing. Color rendering index indicates the effect of the lamp's light spectrum on the color appearance of objects. The higher the number, the truer the appearance of the light on objects. Incandescent lighting, for example, is near 100 on the CRI scale. Most applications should have a CRI rating of at least 70, but if you have a color critical application like retail, 85 CRI or higher is recommended. Caliper, this is a DOE program, and this is like the Consumer Reports of solid state lighting, and it provides unbiased performance information. So LED products are obtained anonymously, and they're thoroughly tested. And then they produce periodic reports that are posted online for everybody to see and evaluate. And they usually come out with a summary report that gives you an overview, and then later a detailed report that provides much more product-specific information. And again, this ssl.energy.gov is a website where you get that information. This is kind of a busy slide, but I wanted to show you this because I want to emphasize that standards and technical support are crucial for the development of solid-state lighting. Many of you may have heard of LM79, and this provides a standard testing method for LED products. But keep in mind that just because a product was tested according to LM79 doesn't necessarily mean it's a good product. It only means that it was evaluated properly. LM80 is a method for measuring the lumen depreciation of LEDs. So this is important because all LEDs lose light output over time. So this is important for you to know. TM21 provides a method that allows you to take that LM80 depreciation data and then make a projection about the lumen maintenance of LED light sources. And this is important because LEDs have a long lifetime, and to wait years to get this actual data is just impractical. So you need a way of projecting how long LEDs are going to last. It's important to have an LED product that is a good product, and one way is to look for approved product lists. And all three of these lists can be accessed through the Lighting Design Lab website. So both of the national LED lists are quite long, and they only include products that meet Energy Star and Design Lights Consortium standards, including lifetime testing. As I mentioned before, that can be an issue, waiting for lifetime testing. Often that takes 6,000 hours to get a good projection. So the Lighting Design Lab list includes products that haven't yet made either the national LED list, usually because of the time-consuming lifetime testing. However, these LED lamps and fixtures, they're expected to qualify for either of these two national lists in the near future. So you can look at the Lighting Design Lab as a temporary list, and the LED products listed there can only remain on that list for a year. It's important to know that Energy Trust of Oregon recognizes LED lamps or fixtures that are included on any of these three lists in qualifying for cash incentives. So before we go any further, I want to go over some lighting terms that help us describe lamps. And unfortunately for some of you, this might involve a little bit of math. The letters that you see designate the relative shape of the lamp, where the number that comes after designates the maximum diameter in eighths of an inch. This is where the math comes in. So, for example, a T8, the T stands for tubular, and the 8 represents 8/8 of an inch, or 1 inch. So that one's pretty easy. But when you get into reflector lamp, which is what the R stands for, an R30 is going to be 3 3/4 inch for its maximum diameter. An MR16, multifaceted reflector, is going to be 16/8 or 2 inches in diameter, and so on. Now, an interesting trend with directional LED lamps is often the letters have lost their meaning. So this PAR lamp, which stands for Parabolic Aluminized Reflector, the LED equivalent has no reflector, but they're still called a PAR lamp just because of user familiarity. So to help us illustrate the many benefits of LEDs, I want to start out by talking about the familiar light bulb. This is one of the main replacement targets for LEDs. In fact, new lighting laws will virtually eliminate the most common light bulbs, which started with the 100-watt light bulb last year and the 75-watt bulb this year. So to replace these bulbs that don't meet efficiency standards, you're going to have 3 replacement options. One way to look at your options is good, better, and best. Good being your energy-saving incandescents, which really are halogens. Better is going to be CFLs, and best, as far as efficiency, is going to be your LED. Now, there's some performance features that will help you decide which of these is going to be the choice that you want to make. And this will also apply for other lighting fixtures as well. Lamp life is one of the considerations. The energy-saving incandescents are going to have the shortest lamp life, where the LEDs are going to be the longest. But LEDs are going to have the highest first cost, but they have the most savings. Dimming is going to be important for some applications. Energy-saving incandescents dim really well, where CFLs don't. LEDs, most will dim well, but some don't. Color quality is going to make a difference for a lot of applications. And you'll see that LEDs, the good ones, can have excellent color quality, but not all of them. So you need to do your homework. So make a choice based on your application, especially hours of operation and what features are important to you. And again, this decision-making process applies to other LEDs as well. So here's some energy-saving bulb examples from GE, Philips, and Sylvania, the big 3 of lamps. Energy-saving incandescents still make sense for applications with low hours of operation and where you want dimming, along with the warm color temperature shift that incandescents give you. CFLs are for applications with longer hours of operation where you don't need dimming and you have infrequent switching, because frequent switching reduces lamp life for CFLs. Now, LEDs are best for applications with very long hours of operation and also if the bulb replacement is expensive or difficult. LEDs also can dim, and they don't mind frequent switching. You can turn them on and off all the time. And I want to draw your attention to a recently introduced bulb from Cree that's available at big box stores. And you can get some of these for as little as $10, which is amazing. And an interesting trend here is that Cree didn't wait for Energy Star approval to launch their product. Remember earlier I said that one of the strengths of LEDs is that they're very directional. So this can make it a challenge to imitate the omnidirectional light output of an incandescent light bulb. So this means you need to pay attention when buying an LED light bulb replacement. The bulb on the left and the one on the right, they do a pretty good job of replicating the ordinary light bulb, but the one on the right has a higher light output. However, the one in the middle distributes much more light in one direction. So this particular LED would make a poor choice for a table lamp where you would want most of the light to shine downwards for reading. However, this one might work out great if you installed it base up and you wanted that light to shine down, say maybe in a task light. So keep this in mind when you select LED light bulbs. So here we're going to take a look at downlights to help illustrate the difference between efficacy and efficiency and how that affects the amount of light delivered into a space. Efficacy, again, is the term that indicates the lumens per watt of a light source. Efficiency describes how much of the available light actually gets out of a light fixture. So in this example, we have a CFL with an efficacy of 60 lumens per watt. However, the number of lumens delivered to a room is decreased when you install this light source in some type of fixture. So in this example, we have a CFL that's installed at a downlight that's only 58% efficient. And this is actually very common. Therefore, the delivered lumens is only 35 lumens per watt instead of the original 60 lumens per watt. Now, an LED downlight fixture or retrofit kit, in this example, it's tested in a manner that rates the lumens per watt for the entire fixture, as opposed to the CFL where just the lamp itself is tested. This is why the LED downlight is rated at 100% efficient. Therefore, you're going to see all 70 lumens per watt can be expected to be delivered into the room. So this is very important to know this difference when comparing LEDs to other light sources. So in this example, the LED downlight is twice as efficient as the CFL downlight and would save 50%. Now, if the existing downlight had used an incandescent bulb, the savings would be much higher. But by any measure, LED makes an excellent choice for this type of application. And this downlight illustration demonstrates one of the many reasons LEDs are so good at getting light to go where you want it to go. So let's turn our attention now to track lights. We're going to find out the many reasons why this is one of the very best LED applications right now. And keep in mind that when we talk about halogen, it refers to a more efficient type of incandescent lamp. So I put up this busy slide because while many of you know that the common light bulb is being phased out through legislation, most people don't realize that the most common reflector type lamps are also being phased out. And what this means is that very soon you won't be able to purchase the most common type of incandescent or halogen reflector lamps. Instead, you're going to have to buy a halogen infrared version of this lamp. Now, this is a much better reflector lamp, and it's more expensive and would pay for itself over time. However, and we're going to talk about this next, the better alternative is to upgrade to an LED directional lamp. So until recently, there just hasn't been an acceptable alternative for halogen reflector lamps for track lighting. CFLs have a poor beam pattern. They just don't have good enough color quality. Ceramic metal halide lamps have been a reasonable choice, but they have shortcomings in light quality and lamp life. But screw-in LED replacement directional lamps, they've improved to the point where they're now an excellent alternative to halogen. And there's many varieties, including the PAR 38s you see here, as well as MR16s. The energy savings and excellent color quality makes them a compelling choice. And maintenance savings is another huge advantage. Because these can last 35 to 50,000 hours, it's going to be more expensive, or it's going to be less expensive, let's say, to buy one LED lamp that lasts 35,000 hours or more instead of 10 halogens over time. And think about the hassle of changing out all those 10 lamps. So this LED lamp qualifies for generous cash incentives through Energy Trust of Oregon, which often covers up to half of the LED lamp cost. So we're seeing paybacks 1 to 2 years for many applications, especially retail. So once you decide that you want to go with LED replacement directional lamps, now it's time to evaluate your options. And this is important because of the long lifetime. You're going to live with your choice for about 10 years or more. So keep in mind, buying an LED is actually a lot more like choosing an appliance than it is a typical light bulb. So it's best to get a few samples and try them out. Directional lamps are commonly made with beam angles from about 10 degrees up to around 60 degrees, sometimes higher, with 25 degrees and 40 degrees being two common beam spreads for LED. The beam spread that you choose depends in part on the lamp mounting height, as well as the distance to the objects you want illuminated. The center beam candle power is going to determine how brightly those objects will be illuminated. So the smaller the beam angle, the more intense the center beam candle power is going to be. So when you test out your sample, look for smooth, tapered edges. Make sure there's no dark spots, streaking, or noticeable color variations. The DOE is going to be publishing a report on the quality of LED PAR 38 lamps in a few months. So be looking for that ssl.energy.gov website for that report, maybe around November. Smaller LED lamps have some challenges. The PAR 38 and PAR 30 lamps, those larger ones, they have an easier time dissipating the heat because of their larger size. However, it becomes much more difficult to manage that heat with smaller lamps like MR16s, PAR 16s, and these candelabra style bulbs. So currently you can find LED MR16s that replace up to 35 watt halogen MR16s. However, it's more challenging to find ones to replace 50 watt halogen MR16s, but we're seeing a lot more coming to market. One of the things you need to know is that these MR16s can be either line voltage, although they're typically low voltage, and they also have different socket types, which we'll cover in the next slide. So some companies cheat a little bit by making their MR16s slightly bigger than standard MR16s. So the two on the right are your halogen MR16s. Here's an LED MR16, but these two on the right are a little bit taller. So that might be okay, but they may not fit some fixtures. So again, you need to try out any LED lamp before you buy a large quantity. Most of your larger PAR lamps come with your standard Edison screw base. Many of the smaller candelabra styles have a smaller base, and you can always get an adapter socket to if you need them. The MR16s are typically low voltage, and they come with pin bases like this. This is one that has pins that are 5.3 millimeters apart. Now some PAR 16s and PAR 20s have a push and turn GU10 base that operates at 120 volts AC, while some of them will have the standard Edison base. So this illustrates again that you need to know what kind of lamp you're replacing so that you get the correct LED replacement. So it's really not that hard. You just have to do your homework and pay attention. So to summarize this section, LED directional replacement lamps and LED downlights are examples of great upgrade options that make sense right now and qualify for great energy trust incentives. So now we want to switch gears and compare LED with some incumbent lighting technologies and applications. So some people are in a big hurry to switch to LEDs, but it's important to know, for example, that linear fluorescent works really well. So because of this, LED linear upgrade options are going to need to be about 40% better in order to be a mainstream competitor or become much lower in cost. Replacing linear fluorescent with LED is only cost effective for a few applications right now, especially ones with long hours of operation and those that operate in cold environments, because LEDs like it cold. However, that's changing fast. So here are some of the key issues that you want to be aware of in determining when to go with LED over linear fluorescent. So cost is a big issue. So LED prices are coming down, but they're still somewhat expensive. Lamp life, fluorescent is going to have 50,000 hours or more, but fluorescent is rated when 50% of the lamps have failed. So 50,000 hour fluorescent, half of them will fail before 50,000 hours, and half of them will fail after 50,000 hours. While LEDs, they may have a lamp life, let's say, of 75,000 hours, but that rating is the useful life. That's when the light output has depreciated 30%. So there's a difference. Lumens per watt, fluorescent, you may have a 100 lumen per watt fluorescent tube, but it might only be 80 lumens per watt out of the fixture. When you get an LED rating of 100 lumens per watt, all those 100 lumens are coming out of the fixture and into the room. Fluorescent is a proven workhorse. While LED is promising, it does carry a certain amount of risk. Controls is very important. Frequent switching is not good for fluorescent, where LED doesn't mind. Fluorescent gets less efficient when you dim them, where LED gets more efficient. So let's begin by looking at some applications where linear fluorescent is used. The recessed troffer is the most common linear fluorescent fixture, which makes it a big target for LED. So the prismatic lens version is the most widely used and the least expensive. One thing you'll notice here is that you get high vertical illumination on the walls. And this type of light distribution can be challenging for LED to attain because of their directional nature. The parabolic recessed troffer was originally designed to help eliminate glare on computer screens and was considered to be a more modern fixture type. But that glare on computer screens is most issues gone away. So a much bigger issue with parabolics is that exposed bare lamp and overhead glare. You'll also notice here the dark upper walls. It creates a cave effect because of that sharp cutoff that parabolics have. So getting rid of parabolic louvered troffers is an excellent retrofitting objective for LEDs. Now you could put LED lamps in these, but this makes the cave effect even worse, more glare, and just not a good idea, which we'll look at more detail here. So many owners and facility managers have been approached by LED T8 salesmen. So this must be a great retrofit option, right? Well, not necessarily. One important thing to know is the light output for most LED T8 lamps can be as much as half that of high-performance T8 lamps. And this shows some testing results that the DOE did. This is a few years old, and the light output has gotten better, but it's still less than LED T8s. The light distribution is going to be different with LED T8s. So your fluorescent T8s have 360-degree light output, where the LED T8 only emits light out of the bottom. It can be as high as 180 degrees, and some of them are 90 degrees. So this is going to affect the light distribution. So it improves the efficiency, but the distribution changes. So this black line illustrates the distribution of the fluorescent T8, where the lower light output and the different light output pattern is illustrated by this red line. Cost, we'll talk about that first. Fluorescent T8s cost about $5. These LED T8s can be $50 or more. Safety is an issue. So while you can get UL approval for the lamps, there can still be retrofit installation issues, and you may or may not bypass the existing fluorescent ballast. There's an issue with color temperature quality and consistency with LED T8s. And a lot of the early LED T8s had premature failure when caliper tested them, but they are getting better. The bottom line is look at something besides an LED T8 for your upgrade options. So a much better approach is to use light bars, LED light bars. So these attach directly to the metal fixture housing, and this acts as a natural heat sink, which is important. So you want to remove the existing lamps, lamp holders, and ballast, then install the light bars and LED driver, which is similar to a fluorescent ballast. And then you could just keep the existing lens, but keep in mind this may not provide the best optics or even the best appearance. But this is the least expensive LED troffer upgrade option, maybe around $70 to $80, and usually cheaper than LED T8s. A much better approach when using light bars is to use a kit that comes with a new modern efficient lens. So this one from Lithonia has a lens that matches the popular fluorescent fixtures like the RT5. So from below, it's hard to tell which is which. And there are a lot of companies that make this type of kit, and there are a lot of lens options and looks available. These kits cost from $100 to $150, and they can be very easy to install. And the lumens per watt out of the fixture, after putting in these new efficient lenses, can be 100 lumens per watt or higher. So here's a couple examples of new LED troffers with different illumination approaches. Finelight and others use a mid-power LED light engine that's similar to the ones that are used to backlight flat-screen HD TVs. Cree has chosen to mount indirect reflecting LEDs on top of a decorative heat sink. So these fixtures usually come in 1x4s, 2x4s, with the 2x2 version seeming to be the most popular. So most of these troffer fixtures are less than $180, and just since I put this presentation together, that price has come down quite a bit. And many of these are competing with the cost of fluorescent fixtures. So this is a fixture that is often used in lobbies, conference rooms, and some high-end office spaces, and it's typically chosen for its good looks and to minimize glare. However, it's expensive, inefficient, and it's difficult to maintain. And you can get an LED version that looks very similar but has much better performance, such as the one you see here. So I want to take a moment to let you know about an exciting option that works really well with LEDs. For very little extra cost, you can get LED fixtures that change their color temperature, either manually or automatically with a central control system. So these color temperature changing fixtures can have very positive effects for your mood, health, and visual acuity. So I highly recommend checking out this type of fixture, and you can go to this human-centric lighting website to get more information about that. Indirect fixtures are very popular for their low glare and even illumination, and there are not a lot of comparable LED versions yet. But one product that has potential is the bulb play fixture from Philips Light-emitting. I mention this because this won the most innovative new product at Light Fair this year. So it has good light distribution, but it's quite a bit more expensive than fluorescent options right now. The fluorescent wrap fixture is used everywhere it should, and a lot of places that it shouldn't. It's a common general use fixture that's inexpensive. The light distribution very wide and even, and it's usually surface mounted, but it can also be pendant mounted. And here's an example of an LED version. I don't know the cost, but I know in order for this to be competitive with the fluorescent, it's going to have to be a lot less expensive. So applications with high ceilings, high bay fixtures, HID stands for high intensity discharge. This would be mercury vapor, metal halide, high pressure sodium. Your low bay fixture has a much wider beam for lower ceiling applications. And both of these fixtures are currently being replaced with fluorescent fixtures, and you can usually save 50%. And it's also common to attach an occupancy sensor to each fixture for additional savings. So because of this existing advantage, LED high bays need to be much better performers. As you can see from these pictures, LED high bays come in many shapes and sizes. And again, because fluorescent works well, it's going to take a while for LED high bays to be a mainstream alternative. The performance is good, but the fixtures are at least twice as expensive as fluorescent right now. So the applications that currently are cost effective are ones with long hours of operation, and especially cold environments like large frozen storage warehouses. LED fixtures work great in this cold environment because they like it cold and they don't mind frequent switching. And the LEDs will come to full brightness instantly. So with this type of LED fixture and sensor in these cold or frozen environments, you can expect savings of 90% or more over existing high pressure sodium. So because of limited time, I'm not going to go over outdoor LED fixtures in detail. Some are cost effective now and some are not. Again, the high cost of the fixtures is the main obstacle. In general though, LED outdoor lighting provides even light distribution, long lamp life, and energy savings of 50% or more. They also work great with controls. So applications you might want to consider are gas station canopies, parking garages, wall packs, and parking lot lighting. The Energy Trust recently added prescriptive cash incentives for these and other outdoor applications, so it's a great time to find out if switching to LED is right for you. Here's another place that I want to ask to use your annotation tools. So let me know which one of these criteria is the most important to you for your application. So in the future, I believe the majority of lighting applications are going to use LED, but for now, there's other good choices. So ambient temperature, we already mentioned LEDs like it cold. Lamp life is going to have a lot of effect on your choice as well as hours of operation. Control options is another big one. And cost, not just your initial cost, but your maintenance cost later on. It's going to be very important. And the looks of the fixtures can be important. The one thing I want to stress is to always consider a mock-up demonstration before getting large quantities. So there's a wide variety of criteria in our audience today. Thanks a lot. So the Energy Trust of Oregon, the cash incentives can provide that extra money you might need to make your LED project work out for you financially. Remember that you have to use approved LED products. So prescriptive cash incentives are available for LED downlights, either new fixtures or kits. You can get $30 for this. An application we didn't talk about that is very good is refrigerated case lights. Incentive, you can get $20 per lineal foot of lamp length and extra money for sensors. As we mentioned earlier, one of the very best LED upgrade options right now is LED directional lamps. And since June of this year, there are incentives for LED troffers and kits and outdoor LED fixtures. And if you don't see it on the list, there's custom incentives available for LEDs, but you must use an approved product and meet other program criteria. PG and Energy Trust can help you with energy efficiency projects for your place of business. Either go to the PG website, or better yet, just give us a call in order to receive a free energy efficiency consultation. Commercial customers should contact Paula Conway. Industrial customers can contact John Maloney. So I know that was a lot of material in a short amount of time. I hope you found most of it useful and that you'll apply your knowledge by undertaking a lighting upgrade project, maybe even one that uses LEDs. So now I want to turn over the remainder of the presentation to Beth for some additional information and to take your questions. Beth?
Thank you, Mark. We'd like to remind you all of some upcoming webinars and seminars that we have, and you can find more on our website at energyeducationcenter.com. Our next webinar next week is Introduction to Compressed Air Systems, and the week after that we have What's New with EVs and Charging Stations. And the next lighting seminar that we have is December 10th, Better Lighting, Lower Costs Workshop in Oregon City. Before we proceed to the question and answer portion of the webinar, I'd like to remind everyone that you can continue to submit questions to me, the host, through chat, and I'll ask them of Mark. And within a couple of days, we'll send you a follow-up email with the recording of this session and the PDF of the slides. And right now, I would like to draw everyone's attention to a polling survey that I just opened up in the lower right-hand corner of your screen. If you could take a few moments to fill out that survey, we do appreciate your feedback and use it to improve our future webinars. And now, Mark, for the first question we have. Regarding the construction of an LED device, are Zener diodes used for this application? Z-E-N-E-R, diodes.
Z-E-N-E-R.
Mm-hmm.
That's actually a term I'm not familiar with. Perhaps if you want to follow up with that question with a little bit more detail, maybe I can help you with that. But something real technical about the actual construction of LEDs, that's not a strength of mine. So I may not be able to help you on that.
That's great, Mark. I'll follow up with the person asking that question and see if they wanted to provide more details and converse with you in an email. The next question is the down lamp CFL example that you used, and I think that was on slide 22, did not mention that most CFL bulbs have labeling that say not to install them in a down application. Why is that?
The reason for that is that CFLs are very susceptible to heat. Heat is going to is an enemy of fluorescence and any electronics, and the CFLs have an electronic ballast built right into them. And when you place them in a downlight, the ballast is going to be at the very top of that downlight, and that's where the most heat is. So it can get very hot in those can lights, especially when you have them in, say, a residential application where They might be in an airtight type of can that has insulation over them, so they get really, really hot. So in general, it's not a good idea to put CFLs in downlights. LEDs are also susceptible to heat, but they produce a lot less heat, and a well-designed LED directional lamp that's used in a downlight is going to be better suited to dissipate that heat and not have its lamp life shortened by that excess heat.
Thanks, Mark. The next question we have is, how much cheaper do you foresee LEDs getting in the future?
Well, I wish I had a crystal ball for that. But what we are seeing, in fact, I attended a rollout of a line of LED fixtures, and was surprised at some of the costs that I was hearing for LEDs. So the projections have been fairly aggressive, but I'm seeing that some of those costs are coming down much faster than just about anybody predicted. So I think you're going to be seeing LEDs become mainstream much faster than any of us ever thought. So this is changing month by month. So keep tabs on the situation and determine when what your price point is for jumping in with LEDs, and then when it reaches that price point, and then you're ready to go. But also keep in mind the cash incentives that are available for especially commercial applications, especially here in our service territory, but other parts of the country as well have incentives for LEDs. And even the cost might be a little high for your application. If there's an incentive that's available, that could bring the cost down to a point where you would want to go ahead and take advantage of using LEDs for your application.
Thanks, Mark. Our next question is, what LED manufacturer is best at getting products listed on the qualifying products lists?
Well, that's a difficult question. There's a lot of them out there. The big three in lamps, GE, Philips, and Sylvania certainly have a lot. And your larger companies like Lithonia and Cooper, and those are just examples of companies that have a large number of LEDs or product family. So there's literally thousands of companies that have LED products listed on the Design Lights Consortium and the Energy Star list. So the best is to take a look at those lists and see which ones are listed most often. Again, being on that list is a starting point, since there's literally over 10,000 products that are on those lists. They're not all super duper products, so you have to do a little more homework to find out a little bit more about the product, not just that it's on a list. That's a very good starting point, but you want to look at other things besides just being on a list. But that's the good place to start.
Great. Our next question, and I think we might have time for two more, is, I like indirect lighting. Why don't we see more LED indirect lighting fixtures?
I was surprised at that at first, that you didn't see more of those, but part of the problem is, or part of the challenge with LEDs and indirect lighting, is that fluorescent linear tubes do a really good job of getting smooth, even light off the ceiling without a lot of hot spots. With LEDs, you have multiple light sources right next to each other, and to get a nice even beam of light that doesn't show imperfections such as color inconsistencies between the LEDs is difficult to do. But a few companies are finally starting to do that. but it's much more expensive than fluorescent. I would say at least twice, maybe 3 to 4 times expensive as fluorescent. So for indirect lighting right now, I think fluorescent is still the best way to go. But we're seeing some LED fixtures like the bulb play that I mentioned in the webinar as being a good product that produces good light, but again, it's still pretty expensive for most applications.
Thanks, Mark. And I believe that was our last question. If anybody has any additional questions, we're going to stay online for a couple more minutes, and you can ask them. I'd like to thank you all for joining us today, and I hope to see you at a future webinar. Thank you.